Now, there are some pretty cool things that we can do. Remember I said early on, this is about a wood veneer that goes to multi-substrates. All of this was metal beams installed on the job site, and all the veneer was installed using contact cement on site. Right? So this veneer, and you guys are gonna, I've got a bunch of sheets here you guys can play with. So I want you to get a feel for it, kind of wrap it, cut it, just kind of get a sense of how it is. And working with a maple, which I have right here, a maple as a species is just a little bit harder than, let's say, an oak or a cherry. Well, I'm sorry, oak is actually also pretty hard, but let's say like a eucalyptus, which is very soft and buttery to handle. So different species will be a little bit different to handle, and so you kind of need to be prepared for that. Each job, you know, it's going to be just slightly different. But you have here, again, another situation on the right that is metal beams wrapped with contact cement. Now, we are now offering a 3M peel and stick option. So in this veneer, and I should have a slide in here, but I may not. You have a 0.2 millimeter slice of wood veneer, which is crazy thin. It's 1/3 the thinness of the normal millwork veneer. And that's only going to happen in Japan. Only in Japan can they handle to slice it that thin and actually be able to build a sheet with the veneer that thin. After the aluminum foil, after the wood veneer, there's an aluminum foil. That aluminum foil is only 0.15. Then there's another 0.15 millimeter paper backer. So it's veneer bonded to an aluminum foil, bonded to a paper. And that aluminum foil gives it a structure, keeps it all kind of in play. It allows us to do some cool folds with it, and it prevents the moisture in the chemistry of the glue from touching the veneer, messing with the veneer. But now we get to maneuver a pre-finished wood veneer to the substrate, to drywall or to metal, and then you see there glass. These are profiles, you know, again, you guys, if you want to even take some home with you to play with, this is how much you can wrap this product on a profile, hard 90 degree, and a good old-fashioned household iron with the steam level, it's kind of its lowest seam setting, is all you would need to make the veneer real soft and buttery. So you literally just take a cloth and that steam, and now the veneer will get nice and soft and buttery, and you can form that just like you see here without it breaking. Kind of a really cool thing. So this is more almost like an arts and crafts process than it is a millwork. So this is really kind of a game changer for the construction industry, because now you can easily retrofit existing materials, especially with the peel and stick. And we've always seen this, in the economy. When money's cheap, you can see a lot of new builds, a lot of new construction. Money starts to get expensive, people try to work with what they've got, and we see a lot more retrofit situation. So this whole conversation we're having today is really ideal when you want to just contact cement or use a peel and stick to existing doors, or you want to wrap kind of profiles and stuff that's on the job site. And if you want to know how much can you actually fold this, like how foldable or how flexible is this wood veneer? Well, this is a rail car project we were doing in Japan. It's like a stupid amount of money to spend a night in a rail car as you tour through Japan, right? But it needed to be non-combustible. So all of this is actually aluminum profiles with the veneer wrapped and bonded with contact cement. That's how flexible it can be. It's pretty impressive. And just getting some steam and getting the veneer soft, and that's being done with the veneer pre-finished. So there's no secondary finishing aspect. Have you, any of you guys ever sprayed finish on millwork? Not an easy process. It's its own skill. And the going rate right now to spray 3 coats of urethane on typical millwork panels is right around $13 to $15 a square foot. That's your material and your labor. And so if a mill shop's not set up to spray 3 coats of urethane, they'll sub that out, and that'll be about the rate that they charge. Even if you're set up to do it, your internal costs are usually right around $10 a square foot. Now these numbers are important because I'm helping you guys understand the value of Sanfoot, okay? Because you can buy from Suzanne these veneers usually from $12 to $15 a square foot. But that's a pre-finished A-grade sequenced architectural veneer done and ready to go. So we're going to be talking a little bit more about millwork and what millwork costs so you can understand again why this is such an incredible value opportunity and why this is such a great way for Merrick Brothers and all of you all here in this room today to make a great income installing this product. So this right here, again, just to show you, this is just a metal wall panel with the veneer wrapped contact cement around that. Look at that. Look at those folds there. Okay. Now this is important because I know, a lot of your clients are going to be asking you to wrap around corners. This is to give you an idea how tight you can go with some steam, with some care, but the rule to make this work is both of these have to be absolutely straight. Absolutely straight. If they're not straight, it will buckle, it will fold, it will do all those things, okay? So, and that's why, and I appreciate you guys having these things here, is there sometimes are profiles when we're getting into drywall, we're getting into gyp, you're going to use some different profiles that we recommend to help you deal with some of those outside corners, because we just know that you've got a lot of linear outside corners, whether they're vertical, whether they're horizontal, whatever. And so you need something that you can go horizontal to vertical, or you can do your 90 degree and you can do your cuts. We want to give you that termination point that looks right, because sometimes you can't always fold it. So this is when you know you're spending too much for your lattes, guys, in Starbucks. So this is Starbucks Tokyo. What you have here is micro-perforated acoustics. We also are partnered, Suzanne will be happy to tell you all about it, as will I, of course, that we are partnered with an acoustic factory. It's called modeacoustic.com. And so we can take our veneer and make, in the same production of veneer, an architectural panel micro-perfed with an acoustically absorbent core. So it is by itself acoustically absorbent. This is what's here in these triangles on the ceiling of the Starbucks. And, but then here you have this metal detail. This was installed using contact cement, but I would recommend peel and stick, unless you guys were dead set on the contact cement. And then this is installed directly to gypsum. This is one of the really cool powers of this product. Sanfoot is a multi-substrate opportunity. Drywall, direct to metal, acoustic. This is like a dream come true for designers. Right? So when we tell them all the things they can do, they don't have to go to that supplier and that supplier. Well, that supplier is going to buy their veneer from this way, and well, coordinating different products and suppliers to all look the same is very challenging to these architects and interior designers. Any questions or comments up to this point before we keep going? No? All right, cool. So who's actually installed this product? We've had a few folks? Okay, yeah. So not a new idea. Here's National Press Building right next to the White House. One of the cool things is that we get to cover a lot of surface area at a good price. So anyone can anyone think of what architectural millwork prices are right now in the marketplace for sequenced architectural? My estimator guys, what's your number? 125, $120 a square foot installed. Yep. See? On point, yes. That is the going rate for sequenced architectural millwork installed is about $120, $125 installed a square foot. The labor alone is $15 to $20 a square foot. Am I correct in that number? I think so. The moment you want to do radiuses or you want to do anything kind of interesting, numbers jump. So the question is, who can afford these days $120 a square foot? I can't. Okay, that's out of my budget. But when you start to, get your neighbor is the White House, it's now you think you would have that money. But even they are, thrifty to a point, because what do you think you would do this at? What would be your number in your head?
Is that
Sanfoot, onto the wall. Of course it's Sanfoot.
I'd say 25 or $30 square foot.
Okay, we're in alignment. Exactly. $120, $30. Simple math, right? I know that's what Robert's thinking. I know that's exactly what Robert's thinking. Okay, it's just absolute no-brainer math. But it's got to be done right, guys, right? Because if it's not done right, then, and I have joints peeling up at the corners, and I've got bubbles and all that sort of stuff, it's a black eye on all of us, okay? And that's why this Sanfoot Pro conversation is so vital, is because we're on the same team, and I want to make sure not only do we not have to go back to fix anything, but if there is something that needs to get resolved, let's just fix it. Why? It's because there's plenty of money for us to make here, okay? All of us. I'm sorry, these guys probably are all going to ask you for a raise now, but this stuff just looks fantastic, and when we get to the radiuses, it just is so incredibly easy. Now here's a prime example. This is Slam Collaborative out of Connecticut was the architect. This is Emory. You can see it's a school of health. A lot of money in the health business these days, but even they have their limits. So the millwork package with all this radius stuff was getting crazy expensive. I would say when you start to get all these creative radiuses, you're probably looking over $200 a square foot by the time you get it, and you'll see even more radiuses. And so luckily the designer knew enough about the Sanfoot directed drywall opportunity and said, well, if we just use from Reglet reveals, and by the way, I always like when these reveals protrude beyond the face of the Sanfoot, so that when you get to the profile, you can cut to that profile and not have to go over the top of it, okay? So just, again, little subtle detail coordinations. And so this was the substrate, and I actually, I went to the job site before all the installation was going to happen, and we had the architect, we had the GC, we had the subcontractor, we had everybody there, and I said, okay, let's us all understand why I'm here right now is because you saved $1 million by shifting to this method, okay, to gypsum. And we do understand that some of that gyp is not going to be quite the same radius smoothness that you'll get with a millwork. There is some acceptance that we can have. Now, my recommendation is always, pay the money, man. Really pay the money for the right quality of gyp, the right level of care, and you're going to have a little bit of those segments there, but one of the most important things I can tell you in any sort of radius is if you think you're going to get a good quality radius with a circular sander that's an 8-inch diameter, no, you're not, okay? Because you're moving it like this. So yeah, you might be able to get a generally flat wall, but we need a flat subsurface. So the quality of our product's only as good as the quality of that drywall. And this veneer will not stretch. There's no stretch in this. So it'll fold one direction or another, but it needs that flat surface. So if you've got low spots and you've got high spots, that's no bueno. It will be it'll create bubbles, okay, bubbles or soft spots. You'll see it very quickly in the veneer. I recommend, and again, I want this feedback from you guys, maybe things you've learned in the field, is the longest tool that you can handle. Some Darby, some tool that's nice and long, and you put sandpaper across the whole length of that, and now you can move that Darby across that jip, and you'll see right away where those high spots and those low spots are. And especially when you get into these radiuses, and sometimes with these radiuses, you may be wise to go ahead and collaborate with a GFRG, glass reinforced gypsum. Build it as a form. Build it as a form, move it in as a component, know you've got a nice clean radius, or I've seen guys or I've heard of guys using sonotubes. Sonotubes, which are those cardboard cylinders you can buy in all sorts of different dimensions, but somehow, some way, that radius has got to be on point. If it's not, it will not look right. Now, in the end, they were very happy with the install. Okay, well, for one, because they saved $1 million, so that would make just about anybody happy. But also, they kept their design intent. But when I look across the light, there are you could just see a little bit of the segments of the gypsum. I get it. There is a reality in when you move from millwork to gypsum, and we're going to have sometimes that conversation with the owner to say, you're going to save a lot of money, but there might be a little bit of things that you'll notice that maybe are different from millwork. Okay, so allow me to be your champion on that, and help you through any of these other things like installing contact cement to the metal doors. Okay, metal doors, or maybe you've got some existing plastic laminate doors. Again, I prefer the peel and stick to these situations. One of the concerns I do have, and because I've seen this problem before, I like this product, HD90 by 3M. 3M is a very good supplier of contact cement. What makes me really nervous is if you go to like a plastic laminate contact, like a Wilsonart contact, that is meant for plastic laminate to an MDF or a plywood core. And it is not a good glue when you're trying to bond the metals. Because if you've got gases, right, all those solvents that are trying to come off of the glue and it's trapped between the metal and the aluminum layer, it will create bubbles. Okay, so that's why I like the peel and stick, because the peel and stick, you don't have that gassing out issue.
So we brought our preferred contact cement. It's another model that you don't have to look at now. But
Oh, okay,
we have
yeah.
reference that's what we
Okay,
use here.
sure.
But that's why when you first estimated some HD90, I know what you're talking about because this is what we use. But
Yeah, and it's only because I can buy this at any home center, and so if I am telling somebody what to use, they don't have to go far and they can buy this, and we know it can work.
okay.
If you know this works and you have confidence in it, I have confidence in it, and that's, I think, like that, and that'll be a consistent conversation that we'll always have together, is that if you've been doing something for 10 years and you have no issues, I want to know. Like, tell me how you've been successful. I want to know how you've been successful, so I can share that with others. But I also want to know where things have been going wrong, so we can prevent that from happening. Right. So this is more of the Emery project, and it's a really great example of when you can't afford the millwork. This is just a great alternative. And what we're trying to tell folks, and everyone's, because the ecology's become more in our view, like, so especially designers and architects are trying to be more cognizant of the environmental impacts. And so this, in the end, is just you get to do more with less. That's kind of the general idea, because you got this this 1/64 of an inch, half a millimeter, that you're going to use a clay adhesive, and you're going to bond that right to the jip. So it's, you're not having to take a lot of stuff from Mother Earth to get the job done. So this is George Mason University. This is all our translucent version. That's a whole nother conversation, but it's being used in coordination with all the veneer directed jip. So we're doing some pretty cool, pretty crazy stuff, and that was a real slick project. But I get specifiers, and I get a lot of folks using the term end match. It scares me, and I'll tell you why. End matching is beautiful, and we can do a great job of end matching. But the moment you take two materials and you turn them into opposite directions so you can have a mirror image of the ends, now the tonality of those two sheets is likely to be different. So this, again, goes back to the conversation. Let's discuss how we're going to lay out each of these jobs before we run the order and before we start making the product. Because we have to make the leaves in such a way in the sheet so that they can properly end match. But I have designers saying, "Oh, we want this end matched." Do you? Really? Do you know what that means? That's the conversation that I need to have. And sometimes we need to save them from themselves. I'm sure you've never had this happen to yourself. We need to save the designer from themselves at the job site and say, no, I know that's what you asked me to do, but trust me, you don't want me to do this. I'm sure you've never had those experiences, right? So in this case, I generally recommend folks to stack match, meaning everything's going in the same direction. So this way, and everything's going in the same direction, you have the coloration, the tonality, everything's going to be the same. Now, I do want to show you this, just kind of get you a sense of a little bit of the history and why this product is the way it is. And you're probably scratching your head going, why am I looking at this old television on this technology? So who's old enough to have the old Zenith and GE TVs? Yeah, okay, yeah. I got to look for the gray hairs, right? Yeah. So those old Zenith and General Electric TVs that were, proudly made in America were plywood and millwork boxes, right? And it was very proudly, in the center of the living room. And humidities, if they get too low, what happens to the veneer? It contracts, right? And if it gets really hot and you're pumping the heat in the house and all the moisture has gone out of the house and now you got humidity that's dropping down to like 25% or 20% relative humidity, now that veneer is actually contracting so much, it's actually trying to pull itself off of the substrate, right? But let's do the reverse. We live in South Florida, okay? And if I don't run a dehumidifier in the house, I'll have 75% relative humidity in my house, even running the air conditioning. So it's just a really wet environment. So in the wet environments, what happens to those TVs? Well, that veneer is absorbing all that relative humidity, and it wants to grow, and it will actually, all the substrate will want to grow, and now the thing just kind of bubbles up and it grows. And that's why the American Woodworking Institute, AWI, which kind of gives some standards for the millwork industry, has a humidity level that's too low and a humidity level that's too high, where things fail. Now, a lot of that's still true for us. A lot of that is still true for us. You can't just install in any humidity, right? We've got our sweet spot. If it's like 30, 35, cool, on the low side. If it's like 60 on the high side, okay. If it's out of that window, we're going to have an issue. And it's not just because of the veneer. It's because the glue, the clay, Romans never tested the clay at 20% relative humidity. They're like, there's just not enough humidity in the air. The glue starts to kick too quick, right? Now, again, you're probably like, what does this have to do with the TV? Well, back in the late 60s, when Sony and the Japanese economy was ramping up, they realized that GE and Westinghouse had all of this problems with these TVs, and they want to solve the problem. And the way they solved the problem by talking with our technical team was, let's slice the veneer thin enough so the expansion contraction rates are way lower. So that's reason one. That's why we started doing it. We started slicing the veneer to 0.2 because Sony was like, how do we get rid of this expansion contraction issue that General Electric and Westinghouse been having all these problems? He said, oh yeah, well by the way, if we bond it to an aluminum foil, then we get a good structure. We can wrap that veneer around that box, and now the TV can get really hot, and these suckers did. They got pretty hot. And now we don't have the glue delaminating and so forth. And there's another industry that really benefited well from that, right? Any guys fix old cars? No, no. Well, it's always the wood dash, you know, that because the old cars that were trying to use the thicker veneers, that's always the thing that needs to get fixed. So we were the first Lexus that came off the assembly line, and you know, still today it's one of our big productions. So getting that veneer thin enough. Now let's kind of give you this comparison of what it is to make millwork and what it is that you guys are going to do as a direct drywall install or direct to substrate install. So the millwork means that you need the face veneer, you need your balancing veneer. So whatever veneer is on the face of the panel, you want to put on the back of the panel, right? So if it's maple here, you want to use same thickness maple here. Now the core is going to be like a medium density fiberboard, and then you got to use some sort of glue, and that's usually done by a layup house. And then you've got either your French cleat system or your Z-clip system, and you got a furring strip there, and so you got 3/4 of furring strip, you got it plus a 1/4 inch on the Z-clip, plus 3/4 inch on the panel. So now you just ate up a lot of your corridor maybe. But that's why millwork, by the time everything's said and done, gets to $125 a square foot. Or there's some other options. One of the other option is, and this is what Suzanne would be happy to supply you guys, as would I, is we take the veneer and we poke tiny little holes in it, and we're bonding it to a recycled fiberglass acoustic core. Now, instead of 4 pounds a square foot of a millwork panel, it's under 1.5 pounds. Easier to install, very easy to engineer, actually costs less than millwork, and because it's easier to install, the labor is going to be lower, but it can still be sequenced. So if you have the budget for millwork, you have the budget for acoustics. That's my lesson here. And then when you get to blend this in with the veneer going directly to the drywall, you're bringing a lot of value to the project and to the owner, right? And folks are often neglecting the importance of acoustics in their space. And I'm just, by show of hands, who's been in a restaurant when you're having a conversation with your loved one and you're literally screaming in their ear? Yeah. I mean, and it's interesting because in Japan there is no acoustic industry because the culture is super respectful. They kind of have a nice little subtle, they speak softly to each other so that they don't impose on others, right? Americans, we need to be heard. I want to be heard. So I want to project my voice. You know, I have something important to say. And that's called the Lombard effect. The Lombard effect is that you sit in a restaurant, you're a little early, it's happy hour, or you show up right before, okay, oh, now happy hour begins. Okay, you order your cocktails. But it's just you and your loved one. And you can have a conversation. And then, you know, somebody sits next to you. And then they're starting to talk. Well, now they're trying to talk a little louder because they want to be heard. They got to talk over you. But now you have to talk a little louder because you have to talk over them. And then somebody sits next to you on the other side. And then that gets even worse. And before you know it, and the place is packed because the drinks are flowing, you're screaming at the person's ear so that you could be understood. So acoustics is all about speech intelligibility. And as we got all freakish about hygiene and, you know, using all sorts of crazy stuff on our hands every time we shook somebody's hand, it meant that the materials in our interior spaces are hard and the sound bounces off and reverbs. And so we need materials that absorb sound. But there's a lot of cool things that we can do with this recycled fiberglass core. And I want you guys to be aware of them because in the end, you're oftentimes the experts in the field being asked, how do I solve this problem? Okay, and that's why I want you guys to be aware of it. So here's South San Francisco Community Center, which is, of course, in South San Francisco. This was a Smith Group project. And they asked me, they said, hey, the mill worker won't warranty the millwork because we want to be able to open the doors, take advantage of that beautiful San Francisco weather, and the relative humidity may be 85%. So the mill worker says, Remember, like we had the TV conversation, right? So what can you offer us? And I said, well, what's the use of this space? Well, that's a meeting room. I said, oh, so you got community people walking around here in this glass building within a building, and you got a meeting room in there. I said, did you think about acoustics? No, we didn't think about that, and that's common. Folks rarely are putting the understanding and the importance of is this space going to function acoustically? Can I actually have a conversation in this space? We just got an order from a school. A frantic designer gives us a call. She goes, you know, it's a shame. It's a privately funded school, so it's private donors, and the acoustic materials got rejected from the budget. They got VE'd out. And now the school is open and the kids can't learn because they can't hear the teacher and the teacher can't hear the kids because of this Lombard effect, right? And all of the sound bouncing off of all the other surfaces. So I said, why would you spend all these millions of dollars to build a space you can't even use? So here's the solution. And they want all that cool radius, right? So we tested the fiberglass core. We were able to be successful up to a 95%, it was actually just over 90% relative humidity. And we were able to kerf the back of the panel so we could ship those panels all flat. And again, these things are weighing under 1.5 pounds a square foot. So we're being kind to you guys because now a team of 2 on a scissor lift can pretty easily lift a panel without damaging it, okay? So, but this was a flat bar metal that went around these radiuses, and they could just simply form and Z-clip to that. And that's by the way, all Douglas fir in sequence. And again, when you get sequence it, all the colors, all the graining makes sense. So we met their fire requirements. We met their humidity requirements. We gave them the sound things they didn't even think about. And then when we got to the 2 lower panels down here, we used the peel and stick we've been talking about to a metal substrate. So this way the kids couldn't, you know, poke holes in it as easily as you know, in the more fragile acoustic stuff. And by the way, when you get into these sort of things, yeah, you need a budget. You need a millwork budget. You need probably $150 installed a square foot or $180 installed a square foot. But that is absolutely where those things are going to be. But you don't have $120 a square foot. And you want this, you know, the beauty of the directed gypsum also too is the gypsum is not moving like MDF, right? So that MDF wants to expand and contract. And that's why AWI has got these limits, right? These limits of low humidity, high humidity. And they actually make a lot of times the owner sign documents, the mill workers, that if they don't climate control their space and there's these issues, like the panel starts to warp or things start to delaminate, they can say, oh, nope, you didn't follow our guidelines, you didn't climate control, you own that wall, right? So that's how the mill workers deal with that. Going back to the design opportunity side of this thing is that designers love sometimes this seamless. You can't do this any other way. This is the only way you get to do this. It either goes overlap and double cut, like you guys know how to do as wall covering installers, on a gypsum substrate, or glass reinforced gypsum. I mean, those are the only 2 ways you would be able to do a seamless wood wall like this. And these radiuses, by the way, in these sort of seamless walls, this is the design trend right now. This is what the designers want right now, okay? We've been looking at all these vertical slats for the last decade, right? we're starting to see that shift away, and stuff like this is what the designers want. So let's do a little bit of wood slicing 101 here. Okay, flat cut. What's a flat cut? Remember, it's the log cut in half. That blade is going very angular against those growth rings. You're going to get all those cathedrals. But again, why those breakdowns and understanding those elevations is that this is going to change as you move through the sequence of the veneer. So we got to pay real close attention to, did we make the veneer, enough veneer for that elevation, right? So when we're looking at the elevations on the drawings with you guys, we're like, what is the client going to see? What is the person that's walking into the space, what elevations can they see, and how does it need to look? We need to know that when we're running the production of the veneer, okay? Quarter cut, log, quartered. Now that blade is slicing very perpendicular to those growth rings, and now you're seeing the edge of the growth ring. The edge of the growth ring is where all of that light reflectance and effervescence of the wood is. It's really, it's kind of, so the light's hitting it, and it bounces back. There's a lot of reflectance quality in the edge of that. Well, that could be problematic in a way when we do book matches, because now light can refract in opposing directions. We get what's called barber polling. I may have a slide that shows that in this. So that's quarter cut. So I do get nervous when people want book match quarter cuts, and I try to sometimes talk them out of it. Rift cuts. Rift cut means now, this is pretty much only on the species of oak, by the way. And the rift cut's the quartered log, and now that timber is on a lathe, so it's got a little bit of radius cut to it. But that's until you understand all this terminology. Rotary cut's what you see in all your plywoods. Plywood is just cross bands of rotary cut veneer, because this is the lowest cost way to slice a wood veneer. And so after they soak the log, they spin it, you get these big sheets, and you get this called like puddling look, okay? But that might be the right choice in certain jobs. Again, we talked about the recons. Recons are man-made logs, called recons or reconstituted veneers. This is the choice oftentimes when I have really big areas. And sometimes you're installing at different phases, okay? Because this is the hybrid of a laminate and a veneer, because it's like a tiramisu. Once you know the recipe, you can make it over and over again. It pretty much tastes the same. Coincidentally, the Italians are expert at this, okay? Because that's all they're doing is they're taking rotary cut veneers, they add color and stain, they put some folds in it, and they make a formula, right? And then they have this block, and then we have consistency. We can slice these blocks and have similarity, throughout the project. I also will guide folks to recons if they have issues with figure, right? So natural woods have character and figure in them, and recons don't. So if I have an OCD lawyer's office, I try to get them into a recon, just because I don't have to explain that trees have limbs, stuff like that. So I try to manage the expectations. So those recons are, again, they're just rotary cut. The color and the stain is in them. And one of our big cost adders is custom stain. It also adds to lead time. So if you can find a recon and you're trying to squeeze the numbers, finding a recon that gives you the color that you want will help you save money. Because this is, see these guys? Right. That's because walnut trees have limbs. They always did. Right? So that's still a double A grade product. It's still something that from our factory standpoint is a beautiful, perfectly good veneer. But and in this project, which is an AC Marriott in Columbus, Ohio, they're thrilled with it. But I recently installed the lawyer's office, which is why I say lawyers, and they're like, well, that's completely unacceptable. Like, are you kidding? Really? Okay. So let's, again, manage expectations. Remember I talked about the, when you book match, which is opening up like pages in a book, and it's quarter cut or rift cut, and the growth rings of the tree, you're exposing the edges of the growth rings, so you have that linear look, and there you see those where the limbs came off of the tree, right? That's all called figure. So the tree's moving around. All of the natural cellulose in the tree kind of moves around a little bit. That's why we want wood. It's the beauty of wood. But this is off-putting to some folks, right? They don't want this. And again, we try to catch this at the point before we order, just to say, and sometimes we'll get the designer and just we want to have a review of what your specification is, what the match is, because a lot of times we'll get them to change their mind. But we can have a lot of fun with directional changes in the species. So here's an antigray. And this is only because they're changing the direction of the species. Now, this could either be done by a skilled tradesperson, or it could be built as a sheet by the factory, where we would build that sheet, that sheet, that sheet. All of these would be done at the factory. And of course, Robert likes that because now it's high value and it's kind of installed by numbers. But how beautiful that is, right? That's a really high value wall. And if you were to ask a mill worker to do this, I would say easily they'd be asking you almost $300 a square foot for it to mill work, right? So you can do your own math of how much you want to charge for it, Robert. But will the veneer cost more from our end? Yes, you might be spending $40, $50 a square foot for the veneer, but you know, you're like, okay, you know, it's if you offer that to your client at $90 to $95 installed a square foot, you're happy you made money, but you also need to make sure that all these gentlemen give the proper love and care to this now $50 a square foot, because if you damage that sheet in the install, that's an ouch. Well, and I think what's happened in the last 30 years is that, first off, this was being sold as a premium wall covering. This was being sold as expensive wall covering. And that was the mistake, because who can justify spending $30, $35 a square foot on wall covering? But when you compare it to millwork, and when you understand, and you have my perspective as the millwork guy, right? And one of my responsibilities was getting millwork wall systems into buildings, and you watch the guys having to set up a small shop because you have to deliver panels to the job site oversized, because you get all the soffits and all the electrical outlets and all those sort of things. You can't you can't manage all that stuff at the shop, so you got to bring the panels oversized, and now you got to do all those little detail millings on the site, and that gets really tough. So when you see this stuff getting installed and you're a millwork guy, you're like, oh gosh, you know, it's a no-brainer. Now, what do we do in those barber pole situations, right? Instead of doing that, one of the recommendations we'll suggest is slip match. Have all the leaves going in the same direction, okay? But that's its own look. Maybe you don't want that. Maybe you want a random assembly. And actually, I like this, one of my favorites, because it just has a more, I don't know, we're used to seeing wood planking, right? And wood floors and things along those lines. And we can intermix quarter cut and flat cut here. We could do what's called swing match, where you change the direction of the leaves. We can integrate multiple flitches in here too, so you get a little bit more variance. So remember, we're building the sheet to the client's desires. And as I said, you know, those end matches, when you got to mirror the image of the ends, you're having to change the direction of those sheets. So now the tonality on the coloration on the sheets up top may look like a different tonality from the ones on the bottom. Now, some part of it is, what is your angle of view? And this is kind of an important topic, because the angle of view is going to have a big impact on how the light is reflecting back at you, right? So I'll go back to this kind of end match. If I'm looking at this end match for the most part straight on, and it looks like the colors are pretty good, okay, that would make sense. But if I'm looking at it and I go to the left, and then I go to the left about 45 degrees, and I look at it, now the color, the top is looking a different color from the bottom. is because my viewpoint is very different. And so that's why end matching when I'm doing ceilings, because now you're looking at a ceiling from a steep angle, okay? Then I really want to keep materials going in the same direction. And we were just at the W in Austin, where it was all specified end match, and I said, we're going to do this as a stack match, because we knew exactly what was going to happen with that. So again, sometimes it's going to fall upon us as a team to save the client and save the designer from themselves. And sometimes it means pulling that designer to the job site, putting those sheets out on the floor, and looking at it and saying, if I do it the way you asked me to do it, this is what it's going to look like. Oh yeah, no, I guess I don't want that. Okay, let's have those conversations. So if you're not sure, if we're not 100% sure, if you don't have somebody absolutely saying, yep, we are all on board with this, do not install. Wait, let's figure out what our strategy is.